Hey everyone, welcome to the zkUSD presentation by Charlie as part of the Navigators program. Thanks a lot for joining us, Charlie. Over to you.
Yeah, thanks a lot. Let me just present my screen. Right, let me know when you can see it.
Looks good.
Everything on screen? Okay. Cool. So yeah, feel free. I mean, this should be sort of like free flow as well. So feel free to interrupt me at any point as I'm going on. If you have any questions, I'm not monitoring the chat or anything, so just interrupt, or we can sort of ask them at the end, whichever's you guys like. But essentially, I'm just going to talk through the feasibility study for zkUSD, which was part of the Navigator grant for November 24. So to begin with, I'm going to talk about the overview of zkUSD and what the purpose of the study was. Then I'm going to talk about the scope of it and then some of the key requirements with zkUSD and a stable coin. Then I'm going to speak about the architecture, so our analysis of what's available and then what the decision of the solution was. I'm going to break down the components of zkUSD. And then I'm going to sort of, with an illustration, I'm going to talk you through sort of the life cycle of what we call a vault, which is a debt position. And so if any of the concepts are just unclear as we start, hopefully that will sort of clear things up, and it will sort of like put things into place if there's any confusion. And then finally, I'm going to talk about some of the high-level protocol stuff, so like the economics of it, and then the governance, and and then finally sort of like the next steps. So the purpose of the study, this was really just sort of like a very sort of highly scoped feasibility study to address whether an exogenous algorithmic stablecoin and its essential components could be effectively implemented within MENA's unique blockchain architecture. Right, so we know that it's possible on EVM. This zkUSD is modeled after DAI. And so we wanted to understand whether it's possible with MENA's unique zk app architecture and its nuances and idiosyncrasies, whether we can actually, within the realms of MENA, build the same sort of thing. Exogenous merely means that the collateral that is used to back up the debt in the system is external to the system itself. So because we're using MENA and we're not creating our own collateral type, that means it's exogenous, which generally means it's a lot safer. So in terms of the scope, the primary goal of this grant was to develop a local MVP for zkUSD that demonstrates all the core functionality. Are we able to create debt positions? Are users able to borrow against those debt positions? And part of that was to do an architectural analysis. Because the design landscape on MENA is quite vast, we wanted to really touch base on all of the different options out there and then really identify, according to our key requirements, what would be the most optimal design for zkUSD. And in doing so, we needed to validate some critical assumptions. One, and possibly the most important for the core functionality, is the computational feasibility. Now, this just means, can we, within a zk app, do all the calculations necessary to ensure that we manage the invariant, which is that there should never be more debt in the system than there is collateral. The next one is, can we have concurrent use of this app? So all the debt positions shouldn't interfere with each other, and users should be able to interact with this without causing any problems. Can we create the protocol in a way that it is self-sustaining in terms of its economics? And then finally, and arguably the most important aspect of a stablecoin and a decentralized financial system like this is the decentralized price feed. Can we get accurate and robust price data on chain so that we can have integrity and stability within the system? And then really we wanted to sort of plan the next phase. This grant, the reason why it's sort of highly scoped to the local MVP was to de-risk it so that we could really understand, is it possible? And spoiler alert, it is. Fantastic news. But then the idea was to, okay, so let's lay out the steps to how we can get this to production so that the MENA community can benefit from it, and it can help the sort of ecosystem, and hopefully be the start of some really cool sort of DeFi products on Mina. So like I said, I'll just run through some of the key requirements. If anything's confusing, it should hopefully become more clear as we go through the illustration later on. But essentially, the key requirements of zkUSD is that the users can create these debt positions by depositing collateral, and they should be able to mint the stablecoin against that collateral and against that position. One of the key components is the liquidation mechanism. Now, this allows us to maintain stability of the system, because when a debt position is under collateralized, then we need to be able to have someone else come in and burn debt so that we can manage the supply, so that we're always 100% sure that the peg can be maintained by having the collateralization of always being able to redeem the collateral for burning debt in the system. And that's how you, in an algorithmic stablecoin, can be 100% sure and maintain that peg of zkUSD. We have a 50% buffer, so you need to be over collateralized by 150%, which accounts for sort of extreme movements in price volatility, and 150% tends to be the sweet spot in the industry at large. So we've just gone with the same number. Layer 1 interoperability, right? This is a very important aspect, because zkUSD needs to provide sort of maximum value to the Mina ecosystem. We wanted for it to be as accessible as possible, and therefore a key requirement was to build this on layer 1. Position ownership. So this is more about sort of like the authorization and access control of the debt position. Only position owners should be able to take actions against that position, such as depositing collateral, redeeming collateral, minting the token, burning the token. But then liquidation should be open towards anyone. Anyone should be able to come in. Soon as someone's not been kept an eye on their vault or debt position, anyone should be able to come in and liquidate that in order to maintain that stability and that collateralization ratio. And then finally, the accurate price feed, which I alluded to in the previous slide. The health factor, which is a baseline measure of the financial health of a vault. We call it the health factor, and it's an internal calculation within the vault. And that relies on an accurate external price, which is essential for the integrity of the system, right? It's one of the key components. So I'll move on to the architectural analysis now. And anyone developing on Mina will sprint headfirst into the brick wall that is the concurrency issues with the vanilla zk app. I'm not going to get into it now, but unfortunately we couldn't just build it out as a single orchestrator contract for all of the debt positions using a vanilla app, so we had to look elsewhere. ProtoKit was the next option, which solves all of the concurrency problems, and they do some amazing stuff to abstract away and do all of the heavy lifting and of the complexity in order to have this layer 2 app chain. But unfortunately, with zkUSD, because the key requirement is on being on layer 1, and each user interaction, be it depositing collateral, redeeming collateral, paying down debt, or minting debt, all of these actions actually require layer 1 settlement. So it really doesn't make much sense to build a layer 2 app chain when every single action requires a settlement to layer 1 anyway. And then the layer 2 chain zco, again, this is isolated from layer 1, so we're only sort of minimizing the scope of the accessibility of zkUSD, and the block time is not really a major concern. So that again was a no-go. And then we looked into the ways of managing this on layer 1 with the sort of action reducer model, and predominantly the batch, because that is the way to handle like the inherent problems of the maximum amount of actions you can have. But unfortunately, a single interaction with such as minting the token can incur up to the maximum amount of account updates. And so you generally only be able to settle one one action per batch anyway, so it kind of makes that whole model pointless, unfortunately. And then finally, we looked at off-chain state, which has a fantastic developer experience, and I really loved it. But again, if we were able to, within the contract, prove that no single debt position had more than one pending action against it, or then we could use this. But unfortunately, you can't do that. So we had to look elsewhere. And the solution that we arrived at was actually having individual, what we call zkUSD vaults, which are individual users' debt positions. And this is really, it seems to have been the silver bullet here, because it solves all of the concurrency issues. All of these individual debt positions are handled within their own contracts, so they don't interfere with other positions. We have centralized or a central token contract, central Oracle contract, and a central protocol vault contract that all of these vaults can interact with to manage some of the protocol level state that we need. But otherwise, it seems to be completely fine to have these individual vaults. And they also solve all of the atomicity issues that we have with the state transitions of the debt position and the account updates of minting a token as well. And then access control. So the actions on this vault, this is what I was speaking about before, about the position ownership. We use a secret that allows anyone who knows that secret to perform the ownership guarded actions on a contract, but then the liquidation can be happened by anyone. And the monitoring of these contracts is facilitated through events. So anyone who's watching, who's a searcher, who wants to take advantage of liquidating a vault, can always keep track of the current financial health of vaults using the events that are published to the network.
Yep. Sorry, I just had a question, Charlie. What is the secret on the access control?
So the secret, we have an ownership secret that we hash when you create a vault, and then anyone that uses that secret can as long as they provide that secret in the transaction, when taking any of these like depositing collateral, redeeming collateral, they can use those actions. So it's not limited to the vault creator; it's limited to the secret that they create.
Right, and is it so it's like the user's responsibility to kind of like store this, like on the client side?
Yes.
To do this actions here. Thanks.
Yeah, exactly. And then they can share it, and then so that can be maintained by an organization or anything, Okay, so just to sort of illustrate how this looks, we've got everyone here with their own zkUSD vaults. Now they interact or read data from the Oracle contract, and they can interact with the token contract, and they can also the fees, which I'll get to the protocol economics later, but the fees are then sent to the central protocol vault contract. And then finally, you've got the community above, which is just watching and monitoring the entire system from these events. So, hot topic now, but talking about the zkUSD token, we really tried hard to try and adhere to the token standard. But unfortunately, as we introduced the decentralized price feed, which required an additional account update, it pushed us over the limit. And so we had to make the choice on, do we go with a decentralized price feed, or do we go with the fungible token standard? And at this point in time, we've chosen to go with the decentralized price feed. What we've done is create our own version of the token contract that absorbs the administrative functionality into the actual contract, which limits the minting and the actions of that, so that it can only be minted from an interaction with a vault, which is incredibly important to manage the supply and make sure that no one can mint. And I guess there's two things to think about here, right? We could together as a community come have this discussion and say, actually, it's more important to adhere to this standard than it is to have a completely decentralized price feed, which I think is a valid discussion. And, so the protocol itself could maintain a more centralized price feed, and then we could use the token standard. Or I think it's really an important moment in time to potentially discuss lifting of the account update limit, especially because we think this fungible token standard, which we want to try and push within the community, it is so expensive within the current limit of account updates. And so if you want any value on top of that to be happen within an atomic transaction, then you're going to be really hard done by to try and like squeeze that into the one, possibly two account updates you have remaining. So I think that is actually, it would be a really good moment in time to sort of enter into that discussion. Okay, so then the price feed. So what we did was we created sort of a completely decentralized price feed, an incentive-driven approach. So what the protocol does is it maintains a whitelist of oracles that submit prices as actions. And as those actions are reduced, we work out the median price from those actions, and then we set that as the price. Now, the way that the reason why we can use the action reducer model to be sure that the actions some rogue oracle doesn't go away and submit hundreds of different actions, bricking the contract, is that we prove that there's no current pending action within the most recent action state for that oracle. So they can only submit an action as long as there's no pending action. And then once it's submitted, that's okay again, they can submit the price. So we use this dual state mechanism, which allows us to have a frequent and consistent price update while ensuring that preconditions remain valid from all of the vaults that are requesting this price data. And the way that we do that is with an even price and an odd price. And to illustrate that, I've just got this terrible diagram. So when it's an odd block, the vaults will be reading the odd price and the oracle will update the even block, and then vice versa. So when it's an even block, the vaults will read the even price and the oracles will update the odd block. And what that means is that we can have a consistent price feed, and the vaults are always acting on the most recent price that has been updated. So the final component is the protocol vault, and this is a core component of zkUSD, responsible for managing the funds and administrative tasks. I'll talk exactly about the fee structure and how that works in the protocol economics part later on. But essentially, the funds are collected from the staking rewards that are held within the vault. And what we do is we fund the Oracle contract from this to pay the Oracle fee. And then we also use those funds for other things as well. And then we also manage administrative tasks such as setting the protocol fees, setting the Oracle fee, and managing the Oracle whitelist. So now I'm going to take you through the life cycle of a vault. Hopefully this will sort of clarify some of the concepts and solidify some of that. So we're going to start with Alice, and Alice has a bunch of Mina, and the Mina price is $1. So the very first thing that Alice does is create a vault. Now, there's many reasons to create a vault. So, here's just a few. Alice might want to have access to liquidity without selling, and there might also be tax benefits to doing so. She might want to natively leverage Mina, right? She might think that Mina is going up, and so she wants to natively leverage the Mina that she has, which will be the first time that she's actually able to do this. And then finally, use in DeFi, right? Yield farming. If out of this, if there are any DeFi lending protocols that prop up, then a stable coin is very important for that, arguably, crucial. And so if she wants to engage in yield farming, then she'll need to mint some stable coin. So once she's created a vault, we can see that the new event, new vault event is published. So the community are able to start monitoring the health of Alice's vault. And we start with a fresh vault, which has a collateral value of 0, debt of 0, and effectively an infinite health factor. So the first step is for Alice to deposit the collateral. This is important to be able to mint zkUSD because we calculate the health factor from the deposited collateral. So she deposits 2,000 MENA into the contract, which submits an event so that everyone can again be aware of the current health of the vault. So now we have 2,000 collateral, 0 debt, and still an infinite health factor.
Hey, sorry, Charlie, I interrupt you, but I kind of wanted to come back. So this zkUSD vault is a zk app which is deployed only for Alice.
Yes.
To manage.
Yes.
Right.
Yes.
I might also read a question which is kind of like relevant from the chat. So Michael asked, can you use user address instead of a secret by requesting the signature for some actions of the user?
Yeah.
Yeah.
Sorry, carry on.
No, that's it. That's the question. Yeah.
Yes, we can, and that's just a choice that we make as a protocol. Do we want to limit it to that one key that created the vault? I think there might be some account update concerns with that. Just because you have to require the signature, so that there might be additional account updates from that method. But really, I think it is a decision on just a protocol level decision, right? Do we want to limit it to the key that created it, or do we want to provide that as a secret that then can be shared elsewhere, and used by different keys?
Cool, thank you. And I guess another question is, this vault is deployed using a particular factory. So if I wanted to create one, is it like a factory of vaults I call, and this deploys a zk app for me? What does this process look like?
Yeah, so the process will look like that they just deploy the contract themselves, right?
Mm-hmm.
The way that they need to deploy this particular contract because it creates this verification key hash,
Gotcha.
which we then use to lock up the token. So we just basically provide them with the code, and if they try to create a fake vault, or if they mess with the code in any way, it creates a different hash, which then is unable to interact with the system.
Thank you.
Cool. So Alice has deposited MENA, and now she wants to mint some zkUSD. So the token minting, and this is why we have that extra account update in there. The token minting is managed through this interaction flag, which I believe is a pattern that's being created by Gregor, which then allows us to ensure that the interaction with the vault, the minting of the token can only happen from the interaction with this zkUSD vault. And we also use the verification key hash there. So we're 100% sure that no one can come into the token vault, the token, and mint the token outside of this cryptographic proof. So in order to do so, we go to the Oracle contract and we get the current price. And according to the price, we calculate the health factor, which is this baseline calculation of the financial health of the vault to ensure that it's over 150% collateralization. And that's baselined at 100. So anything over 100 is okay. Anything below 100 is at risk of liquidation. And it's up to the user to manage the health of their vault. So as long as everything's okay and we calculate, yes, Alice, you've only requested 500 zkUSD, you've got 2,000 deployed within the vault, you're okay to mint that debt and to mint that stable coin. So then that is minted to Alice's address. And again, the event is published to the community, so the community is aware of the current state of the vault. So the next step is, Alice thinks, hey, I've got too much collateral in there, I don't need that much. So she's like, okay, I'm going to withdraw some collateral from that. So she will then send the redeem collateral function, call the redeem collateral function on the vault, which, as long as the health factor remains above 100 after the withdrawal, then the vault says, yes, that's completely fine. And if it would fall below, then it won't allow Alice to withdraw her collateral. So we always need to maintain that health factor. And we do so through the Oracle contract. And we, at this moment in time, we check whether there have been any staking rewards that have accrued on the vault. And if so, then we take a siphon off a portion of those as the protocol fee towards the protocol vault contract. But I'll talk a little bit more about that later. So right now, Alice's vault, it has 1,000 collateral deposited, 500 zkUSD has been minted, and she's got a current health factor of 133. So Alice was feeling a little bit worried about her health factor. So she decides she's going to pay back some of her debt. And so she calls the burn zkUSD function, which this one's very simple because the health factor can never fall lower than when you're burning debt. So she just simply decides she's going to burn 100 zkUSD in order to increase her health factor. And so she does so, reducing the debt in the system and increasing her health factor. Right, so now, unfortunately for Alice, she goes on vacation and she's a bit of a silly sausage and she forgets to take her phone with her or doesn't check on her phone or the market. And unfortunately, there's a series of price drops and the health factor of her vault becomes below 100. Now, as the vault has been monitored by the community, Bob steps up, and Bob, with his fat stacks of zkUSD, is ready to liquidate to take advantage of the zkUSD that's inside the vault. And so we move to the next one, which is Bob liquidating the vault on Alice's behalf. And so Bob pays the current debt, which was 400 zkUSD, in order to claim the collateral inside. Now, as long as the price is below, so the health factor is below 100, then this action is allowed. Otherwise, it is not allowed. And then again, this is sent off to the event is published to the community. The community knows that this vault is now being liquidated. One thing to note here is that the liquidation penalty is quite steep. Alice loses all of her collateral in the vault when it gets liquidated. And this is something that, we can tweak at the protocol level. We can say, okay, you know what, Bob can maybe get a 10% liquidation bonus or a 15%, and then we can leave some left in there for Alice to come in and collect, after she realizes that her vault has been liquidated. And that's something that we can sort of tweak later on. Okay, so does anyone have any questions? Are there any questions in the chat, or anyone has any questions about that, the life cycle of a vault?
Hey, Kobe.
I'm wondering what happens if there's like 50,000 vaults and there's a major price swing and like half of them become liquidatable. I don't know that the network could process 25,000 transactions. I think it could take like days.
Right.
And I think that's another network upgrade that might be required to sort of make this realistic. I guess I'm just commenting that. I don't have a question, but if that's something that you've considered and you think I'm wrong, I'd be interested to hear about it.
No, that's a valid concern, and I think that's something that we might need to look at, right? We might need to go to Zico or some other instead of layer one. If that is something that we, if there is a cutoff point where we say, here's the line in the sand here of there are some, there might be X amount of vaults, and then that would cause this kind of problem, because that's obviously a problem with the system. Another thing that you could do is really crank up the over collateralization ratio, so that you do have, so it's rare that you do have price drops of over 50% within 3 minutes or within that short amount of time. So we could crank up the ratio so that that's more of a gradual thing. But definitely, thank you for raising that. I'm not aware of the limits of the network can actually process and what kind of vaults and the amount of vaults that we would expect. So we 100% need to do some due diligence there to make sure that we're making the right decisions and we're calculating the risk properly. Because that's obviously a very valid concern.
One other design lever you could do would be like add a settlement period where these actions like liquidating, burning, withdrawing, creating, like anything that's going to change the amount of zkUSD in circulation could potentially have like just a waiting period of quite long. Like it'd be a bad user experience for sure.
Yeah.
It would make the system more secure, I guess.
Yeah. Yeah, that's cool. Definitely worth looking into for sure. Yeah, it's definitely there's a fine line, isn't it, between too much, 99.999999% risk versus 99% risk versus the user experience as well. So that's something that we need to figure out. The balance is there for sure.
I'm just going to read out some questions from the chat. So Michael asked, do you filter the prices that are far from the average when calculating the average price? I believe this is for the Oracle contract, but Michael, please correct me if I'm wrong.
Do I filter them? So the median price is worked out. So it's not the mean price, which allows us to have some outliers. If there is a rogue Oracle, it doesn't affect the price. We just calculate the one in the middle. We also have actually something called a fallback price, which is the protocol itself will submit the price to the Oracle contract every block. And as long as if there are less than 3 oracles submitting the price, then we will pad an array which calculates it. So as long as there's less than 3, up to 3, we will use the fallback price. Otherwise, we use all the oracle prices that have been submitted. Now, the protocol will maintain the whitelist of oracles. Right now, that's set at 10. And these are going to be trusted members of the community. And we'll also develop Oracle software that these oracles can run with their chosen price provider, so that there's no risk of them of anything happen from that perspective. But if there is oracle that gets taken over or decides to go rogue, that is de-risked by the amount of oracles that we have and the median calculation that we do.
All right, thanks. And I think my next question is probably more generic, and I'm sure this applies to all ecosystem projects too. What happens if the Oracle contract price is not updated in a particular block? So are there any is there a time frame buffer which the liquidation looks at, or does it make no sense to have something like that?
I mean, yeah, it could make sense for sure. We do. So there is an emergency stop thing that we've developed into function or mechanism that we've developed into the Oracle contract. At this point in time, it's only called by the protocol vault. So the protocol vault can manage whether there's an emergency stop. And if there's emergency stop, then basically the whole system pauses. And yes, we can add some fail safes in there so that emergency stop is kicked off as if that price is not updated within 2 blocks, for example, we can kick that off. So yes, for sure, we can tweak that into the system.
Cool. And thanks. I have one more question from Michael. So he says, can you just burn some percentage of zkUSD during liquidation to return the health factor to 100?
Are you talking about partial liquidation? So probably, yeah. So that's not designed into the system now. That is something that we could potentially look at. So right now it's just complete liquidation. I would need to have a look as to what's possible there and what we want to do as a protocol. I know in the first iteration of DAI, they also just had full liquidation, but now in the way that they're managing their vaults, they can do partial liquidation, and it really depends on if we look at what the limitations of MENA are and whether we're able to manage that. But it's definitely something worth exploring of doing these partial liquidations.
Yep, thanks. There are no more questions from the chat. So
okay, brilliant, thanks. So yeah, now just talking about the economics. So as the protocol, we can run our own infrastructure and run our own staking node that participates in proof of stake, and we can, as a vault is then deployed and its collateral is delegated to our staking node, then that vault can start earning rewards based on that, which will accrue within the vault. And then when a user redeems collateral, we can work out exactly how much has been accrued, and we can siphon off a percentage as part of the protocol fee. And these funds can be used to pay for the Oracle price feeds, to develop further initiatives, and to fund the protocol's development. And then finally, it's prudent to create a sort of solvency fund, which is like a lender of a last resort. And kind of what Kobe was talking about, right? If there's massive increases, massive drop in price, and more vaults become before the liquidation can catch up, and there's less debt, there's less collateral than there is debt out there. We can buffer that with any solvency fund that we're able to create. So it's important to think about that in terms of platform stability. And the user benefits of this is pretty cool. Where essentially this allows users to take out negative interest rate loans where the staking rewards effectively pay off the user debt, which is a unique sort of DeFi feature of zkUSD. And then they get all of the extra benefits of being able to mint and use their mina for this purpose. And then just a little touch on governance. So we have an idea of progressive decentralization. Currently, the protocol vault is governed by a single administrator key, with the idea being, okay, well, pretty quickly we're going to think, okay, so how can we decentralize this, and which might involve using a multi-sig to begin with, and then sort of exploring the differences, like can we create a DAO on Mina and have more community-driven structures that enables us to manage the platform that way. And the end goal would be to maximize decentralization, where appropriate, and to ensure that we're secure, we're transparent, and we're resilient, and this is a community focused thing. So that's really important to us here, and I'm sure to Mina as well. Okay, so finally, I'll just talk about the next steps, right? So I haven't gone through any of the code, and I'm more than willing to do so if you guys want an additional session to talk about that. But essentially, this grant was to prove that it is possible, but we don't want to stop there. We want to continue on and move this towards production. And so the development steps will be sort of a full integration test suite, right? We've proven this locally. Can we now get it working on Lightnet and DevNet? And are there any hurdles to jump over in doing so? And sort of considering, some of the aspects like what Kobe mentioned, and considering the acceptable risks here. We want to develop Oracle software, like I was speaking about before. All of these trusted oracles, we want to provide them with maybe a Docker container or something that they can then run to provide the price and to get the Oracle fee. We also want to build out a user interface to allow users to interact with vaults, to set up vaults, to see their position, and potentially have our own backend where we monitor the financial health of the system, of the current platform protocol statistics, and provide a place for users to see the current health of the vaults. And then finally set up the necessary infrastructure, which we need to delegate the stake to, so a proof of stake participating node, and anything else we might need. Pretty soon after that, a smart contract audit is going to be really, really important, especially something of the importance of zkUSD, where we want users to be locking up real value. It's really important that we make sure that there's no vulnerabilities with these contracts, to ensure that their collateral is safe. We need to think about protocol governance. So seek any of the legal and regulatory advice with setting up a protocol like zkUSD, and set up any of these necessary governing structures, so that we can move quickly to begin with, and then start defining this roadmap for progressive decentralization to hand over as much of the power to the community as possible. And then finally, kind of zkUSD is pointless without money markets to trade it. It doesn't maintain a peg. There's nothing there. So initiate discussions with exchanges to list zkUSD post-launch, to increase the surface area of it, make it as accessible as possible, to provide as much use to our users as possible, and increase the adoption and liquidity of zkUSD. Thank you very much. That's it.
Awesome. Thanks, Charlie. if anyone in the audience has a question, please like raise your hand or come on stage, whatever you prefer. In the meantime, maybe I can just ask Charlie if you could briefly describe how are you hitting the account update limit, if you can walk through the actions which are there, because we also have Philip on the call and maybe he has some ideas or
Yeah, sure. So
questions. Yeah,
absolutely. So I've created a GitHub discussion on the actual repo for this, which really goes into detail on the actual account update limits. But essentially, we're looking at about really at the limit for just minting, because in order to lock down the interaction with, to make sure that minting can only happen from our zkUSD vault, we need to use this assertion flag, interaction flag pattern, which means that not only do we call the admin contract to determine who can mint it, but then we need to also call back to our vault contract to call this flag. And so with that extra step that's required, that really puts us right at the limit according to the standard. And then just that price feed on top of it to get the current price pushes us over the limit. So yeah, I looked at a bunch of different ways we could do this, and so yeah, I could. That was the choice that we had to make between the price feed and this. And again, like I said, if we think it's really important to have this to have the standard adhered to, more so than like a really decentralized price feed, we can do that, right? We can, as a protocol, we can make that decision, and if the community accepts it, that's the most important thing. Or we can think about this account update limit, and ideally we don't want to wait too long, right? I'm very much of the mindset of wanting to move fast and get this out there and get this used by the ecosystem. And so, if you turn around and say to me, yes, we can increase the limit, but that's going to take next year or the year after, then, that's obviously not a viable thing to consider now. But yeah, so that's where we're at currently with our decision making. But happy to open it up and to change, yeah, and be flexible there.
Thanks. So Kobe also writes, it's also necessary for other zk apps and programs to build on top of this for room to add. Yeah, certainly. Hey, Michael, go for it.
Yes, the question. One of the solutions I see, because basically, of course, I want to have both decentralized oracles and all that stuff, is to install those wallet zk apps into the token accounts of fungible token admin. So you don't need the flag in this case, because you go through the admin to do anything with such contracts in this way. And you're saving some account updates. And also because you just mint usual tokens on fungible token, you don't have limits on interaction with other contracts. That is very important, like Kobe is saying right now. So I would recommend also to US protocol to look at the possibility to deploy your wallets not to the simple public key, but to public key token ID, meaning that it's token ID of fungible token admin. And you're fully free to basically use fungible token admin in any way you want. So maybe it will solve some, of course, it needs to be checked, and the account updates is very difficult issue. I'm just personally spent maybe more than a week of my time in the last months trying to optimize account updates for my contracts. Not always successful, because there are cases like swap of the tokens when you just cannot do it. You short of accounts updates. But probably it can help. So I would recommend you to look into this direction also.
Brilliant. I didn't follow that 100%. So do you mind, like, if you have some time, do you mind just like detailing that out on the discussion on GitHub? I would be really, really appreciative if you did that, and then I can definitely just run away with that and investigate it and see.
Yes, I will write a short message describing in details how it can be done.
Thank you.
Yes,
Appreciate that.
it's actually very similar to how NFT is organized.
Yeah.
And it's why I'm proposing it, because I have already experience of doing that stuff. So there are some examples you can follow to understand how it is working.
Oh my God, it just clicked. Your DFST. Awesome. It's great to finally put a face to the name. Okay, cool.
Okay.
All right, thanks. I'm just going to read out a question from Anuj in the chat. Anuj says, considering the price updates will be lagged by like 3 minutes, which is the block time, since you're considering having the price feeds directly on chain, what do you think about the arbitrage in general regarding to the overall performance?
I mean, this is the trade-off, right? I think you could, if you have a centralized price feed, you could constantly be having the price. If you then lock it down from the person that's signing the price, as long as every time a user requests it and then uses it on chain, as long as it's locked down to that specific block, you have more granularity of when they process that price. But with the lagging pattern, it's still going to be the most up-to-date price that we have. It just means that was the one for the last block, rather than the one that's going to be submitted, because we just don't know when that is processed by the block builders, and are going to invalidate all of the other price, the transactions that have happened. So this is the best solution that we can come from. Again, if we were built on zkO, this might solve this, right, because of the block times, and that's decisions that we have to make as a protocol, right? This is the most recent one that we can get on chain every time. And if you don't have it on chain, then you don't have decentralization, because you have one signing key that you have to store on chain. Then that's your single point of failure. And if we do that, if we make that decision to have that, then that's cool. We get rid of this account update limit as well, and some other things.
Right, awesome. Thank you for answering. So there are no questions in the chat, but maybe I have like a very generic one, because you always see sometimes these stable coins lose their peg, like go from 1 to like 0.93 in some cases. So can you explain is that something which is possible, like with any stable coin? Is there something we are doing better over here? Or
no, so they can always lose their peg, right? And they often do, right, through trading. But the inherent design of the system is to ensure that peg. So if suddenly it starts trading above $1, then users, you can just come to the platform and you can mint some more token and sell it on the market and make and arbitrage that way, which provides extra sell pressure, which brings it back down to 1. And if it's trading below $1, then users are incentivized to buy it from the market and pay down their debt, because it makes it economic sense to do that. So then you're always guaranteeing that sort of price around $1. Now, we've modeled this after DAI, which is probably the most proven and tested stablecoin out there. Obviously, we all know what happened with Terra and Luna, and we definitely don't want to do anything like that. So yeah. That peg is maintained through the structure and the economic incentives involved with the platform, and then so that it's an inherent design to how you can always redeem and contract the supply that way.
Thanks. Okay, Kobe, go for it.
So actually, DAI today is a multi-collateral platform, and this is more reminiscent of what's now called Psi, which was the original Ethereum-backed single token. But what's interesting about DAI is it's now mostly backed by USDC. So there's some risk there that if Coinbase wanted to like take DAI down, they could. But there's obviously a roadmap here to a multi-collateral system as well. It's not impossible. Absolutely.
And I think as we're very greenfield, right, with Mina at the moment and zk apps, and especially the DeFi ecosystem is very new. You've got the first DEX that's coming out soon, it's doing testing, and so I think we have to take the necessary steps before we can get to something that is as capable as EVM, as ETH, right, to be able to create these amazing different financial products. We're sort of like taking that same journey, but with zk apps, right, which is awesome. But we also have to make sure that we're doing that in the right way.
Thanks. I guess one last question is, how do you see will this can these stable coins be safely exchanged with like layer 2 like rollups like protocol app chains, or do you see like some issues? It's better to have them all contained on L1.
I think that I'd have to investigate it properly. But as far as I'm aware, of course, we can use these sorts of ways that we do bridging between layer 2s anyway, and to do rollups. We can implement the same sort of patterns to get and that's the idea, right? That you develop it on layer 1 so that then it can be used on layer 1 and all of the layer 2s as well, right? You've got USDC or USDT on all of these layer 2s, and that's the idea with zkUSD, that you'd have it on the layer 1, and then but also within the app chains and within zkO, for example, as well.
Gotcha. Thanks. I don't have any more questions. I'm just going to scan the chat, and if anyone in the audience has, please take the stage.
Maybe not a question, but very opinionated, personal kind of opinion, I guess, is that, I think at the end of the day, having a fully decentralized price oracle, the struggle from the perspective of developers to integrate additional stablecoin that could be the stablecoin to be used, it's kind of better trade-off than having to, have some trust changes with the whole design, and then having other problems that then come from it. But I guess the biggest ones are wallets. I think that, especially for users' experience, that might be the worst one to having to figure out. And obviously, adding this normal support for fungible token and for zkUSD, for example, that's also just an additional kind of problem. But hey, trust versus user experience, in my opinion at least, should go definitely more to the trust side. So
which is, I agree with you, Carol, which is why ultimately we have made the decision that we've made. And then I did, we can look at what Michael's, if what he's done is able to work, then absolutely fantastic. And if the network can increase the limits, again, fantastic. But I agree with you. Decentralized price fee is more important than this extra step for developers to integrate the stablecoin, especially because the stablecoin is such an important token, and it is as a DeFi primitive, it's important. And so, as far as we're concerned, we think that developers will take that extra step in order to integrate it.
Yeah, I agree.
So I want to get your opinion on, so when we look at the algorithmic stablecoins on the market, I think the main problem with them is their scaling problem, which is basically you only have the resource of on-chain liquidity, not the outside of the world. Absolutely, it's trustless, better than what we have within Tether or like Circle. But I'm curious about what do you think about scaling the product to masses? Because right now, the on-chain liquidity right now is only limited with the Mina token itself, and I'm not sure how to make it a $1 billion product.
Yeah, sure. And this is the problem that actually caused the massive crypto crash of 2022. So the endogenous kind of stable coin, which is the algorithmic kind of like the Terra Luna design, they create their own collateral, and then they have a system that basically is able to scale because of the way that they design their algorithm, and the fact that you can always mint more of that collateral as long as the demand for the stable coins increasing. But the trouble is, once it gets devalued from the peg, you enter into a death spiral, and then so we have to make that choice. What do we want? Do we want infinite scalability, or do we want safety in the market? And I think most people want safety in the market.
Yes.
So there's potential things that we can do research as well. We can think, okay, well, I know there's some stable coins where it's partly, they take some part which is internal to the system, which allows them to scale a bit higher. But yes, you hit the nail on the head, right? That is the problem with these stable coins, is that you're only able to have as many in the system as collateral is backing that up, which I think is more of a feature than a bug, especially looking at what's happened and the kind of untold damage that occurred from the Terra Luna collapse. So I think any we would be reticent to take any action where we are sort of like, you know, trying to follow their kind of model, and it should be highly researched by smarter people than myself as to the real tweaks that we can make in order to increase that scalability a bit, but also remain safe.
I think like the best way to do it is basically having some kind of tokenized products as an like real world assets from. And I think like if we could use them as a collateral, I think that would allow us to scale it in a safer manner. But
Sure.
like absolutely, we are so far away from it today. But that would be much better than what we have today.
Definitely worth exploring, right? I mean, who knows what's in? Is it Bitfinex? They do USDT. Who knows what's in their vaults, right? But if we could collateralize real world assets, for sure, that would be a great way to be able to do that.
And I think it's the main reason why most of the lending protocols are spending their time on like having some collateral as in an off-chain way. But I think it also can be done on-chain. Yeah, we'll see.
And maybe like, I mean, with Mina's zero knowledge proofs, right, and what it's all built on, that could be really cool use of Mina, right? That people are willing to do, like, we can prove that we have these assets, you know, on chain using these zk proofs. There would be a really powerful implementation of that feature. So definitely worth exploring. And 100%, this is why we're collecting that fee as well, like to fund the protocol, to fund this kind of research. So that we can start to build out on these initiatives and further develop maybe a version 2 or a version 3 or other DeFi products, right? That's definitely what our eyes on the horizon and our vision for zkUSD is.
Yeah, great. I don't have any other comments.
All right, I'm going to read one out from Anuj in the chat. He's asked, have you given any thought about tokenomics to make the project self-sustainable, and what percentage are you thinking?
So that would be a thing when we're thinking about governance, right? We can think about creating a governance token about it. We need to look at what's possible by designing such a system within the zk app. Right now, the protocol is self-sustaining in terms of we don't need a token because we get the fee from the staking rewards, which I think is a very powerful feature. But we'd have to be careful to make sure that any sort of design that we have in terms of creating a token or a governance token, is that possible within Mina to have a DAO and to have voting and all of that lot, and then also, you know, are we designing this for the community in mind? So absolutely, we'll be open to explore these different ideas. Right now, there's no plans for it. But if we figure out that the DAO is possible, then yes, we need to figure out, okay, so how's the voting happened, and are there any things that we can do around that? So yeah, that's something that we definitely need to consider as a protocol.
Thanks. Anuj also says staking racks up after 15 days.
Yeah.
To plan on locking every deposit for the first 15 days if someone wants to mint.
I don't think so. I think we can just let it in there, right? And just say, okay, well, if you're only literally gonna mint it, you know, you don't get any staking rewards, you know, we don't earn anything. That's complete. I think that's completely fine. And then we're just gonna take the fee from the long-term users of the platform. I think that's okay.
Also, many more questions from the audience. None. So hey, Charlie, thank you so much for walking us through the work you've done in such a short period of time. I don't know how you do it, but really impressive. And thank you all for joining and helping this conversation. I hope you all have a good day. Thanks.
Yeah,
bye.
You too. Thanks, guys.
Thank you very much, Charlie. Thanks. Bye.